John King, and this is Jessica Smith. We're with Sky Teach. And Jessica and me wanted to tell you a little story today about what happened to us.
Okay, so the other day, me and Levi decided to go hiking. And so we're going through the woods, and I'm following behind Levi because he knows a little more about the area than I do. And he's turned around and he's looking at me, and we're talking, and clumsy Levi falls into a well. So the well is too deep for Levi to climb out, and it's too deep for me to reach him to pull him out. So
So we're in the woods, and there's not really much around for her to help me. It's not like we got any supplies. We weren't expecting something like this at all. So the only thing that Jessica has around her is rocks, and they're all relatively the same size. I guess we're around a quarry or something. But those are the only things that she has. So how do you think she would be able to use the rocks in order to help me get out? Does anybody have any idea?
Well, because I gotta hurry up and get him out. I mean, he can only tread water for so long, so we got about 15 minutes for me to get him out before he drowns. So I have to think fast. If all I have are rocks, what do I do? Cry.
Throw a rock in the water, hope we don't hit it.
Okay, that is excellent. Now, why would I put the rocks in the water?
Because when you drop the rocks in the water level rise.
Okay. So how many rocks do you think that it would take me to get Levi out?
I think I don't have to see this well to say.
And how deep is it? How deep is the water?
Maybe like 100 rocks.
So
Well,
it's about, the water level is about 30 feet. And the distance from the top of the well is about 20. And that's why she can't reach me. It's quite a bit.
We would have to weigh the rocks.
Mhm.
To find this.
well,
So we have a model here, and we are wanting to see how many rocks it may take in order to get me out of the well. All right?
well, we're going to do an experiment to figure it out. So our experiment is going to tell us about how many rocks I would need. And if this is our well, then we need to know how many rocks we're going to put in it. And when you put the rocks in the water, you were correct, Karan, and the fact that it moves the water up just a little bit. So our experiment is going to be putting the rocks in the water to see how far we can get it up. These are going to be your wells. And before we pass out the materials, I want to give you a little instructions. All right, everybody's going to start off with 30 milliliters of water, which represents the 30 feet. And it's going to take 50 to get Levi out. So we're going to group you accordingly. In the back, the three of y'all are going to be in a group. If you will move up, you'll be with Timmy, Tommy, y'all be a group of 2.
Started that.
And y'all are going to be a group of 3. Y'all are 2, and y'all are 3. Okay? All right. One person in your group will do the mass for the groups of 2. One person will do the mass. One person will do the water displacement. Okay? Are you listening? Because I hear talking. If you're talking, then you're not listening to me. This is very important that you listen to the instructions. You're not going to know what to do when you get your materials. So one person's going to measure the mass using the scale that we provided. The other person's going to measure the volume, which means you drop the rocks in, you see how you're going to measure the water displacement. And if you have a third member, then the third member can be the recorder. If you don't, then you can take turns recording your information if you're in a group of 2. Okay? All right, please raise your hands when you are finished or if you have any questions. And when you're finished, we're going to use this graph, and y'all are going to come up and graph your results so we can see what everybody got. All right, once you get your wells, you can begin. Got your well.
Thank you. Can I grab my one? John,
I'll play this one.
They look really
What's up?
Imagine all the rocks. Massive rocks.
Don't forget to put all the group names, all your group member names on the worksheet.
Looks like.
We have one very bad reason, so I replaced it. Y'all done?
Yes, ma'am.
Okay. Do you want to graph your results? All right. Since you're the red group, you're going to use the red addition. Take the worksheet up there and y'all put your red push pen.
All right, you guys are yellow. Great.
For the yellow group?
No, I'm gonna ask.
No, yellow. I said that's fine. That's fine.
We just didn't know if that was.
Tell me about it.
Yes.
Hear me.
So what happened up there?
Mass is 21, mass and water level. The
This should be like family photo.
Wait, what color are we?
Kids are really like, oh,
Yeah, this is us.
Do we have the best?
I hope so. I really do. Well, it's like cause probably. That would be
And we were the only color left.
All right, class, so we have our data right here, right, for all the groups, okay? So from this graph, all right, so how many rocks did the red group have? Which group is
red group.
red? All right, so how many did you guys have? 2? All right, so what did the green group have? 6? Okay, so there's a big difference between 2 rocks versus 6 rocks, right? So why do you think that when you put more rocks in, more water was displaced?
It takes up more space.
Takes up more space. All right. So if the water takes, or the rocks take up more space, right? We want to know how many it will take for Jessica to get me out of the well, right? So if we have 2 rocks here and 6 rocks here, right? And the water level is going steadily up, how many rocks do you think it might take to get me all the way out of the well?
I say 12.
12? And, yeah,
I say 7.
7? Why 7?
Because 2 is above 30, so that'll, the water overflow. And then 1 more than 6, there's 1 less than 2. So 6 is
7? So, let's see. If we had 7 rocks, right? So let's see, we have 25. our mass is 25 grams, right? And the water displacement is at 40, right? So, let's see, as we keep going over, it keeps increasing by about 5, right? 4 or 5. So if we put one more in there, where do you think we'd be on this chart?
45.
Nah,
45?
nah, because it took 6 to get from 30 to 40,
Mm-hmm.
so it'll be like 42.
Probably 42. Yeah. So as we keep going up this line,
It'll take a lot.
right? So let's see. So we got, let's see, 50 right here, right? And we have a string, so 45.
Somehow you
So,
need to
yeah, it
make the
would probably
students
take
do the
about
work
12,
instead of you right now in the
right.
previous 2 minutes.
Okay.
All right, so, okay, if wood is lighter to transport, so it would be easier for me to carry a bunch of wood if I happen to have some wood around, because I mean, we are in the forest, so we have trees and stuff. If there was some branches that I found, like big logs or something, why would I want to use rocks instead of, like, why would I use rocks instead of wood?
April?
Because wood floats.
Okay.
Why does wood float? Does anybody know why wood floats?
They did because wood's like less dense than water,
Okay.
maybe, and then the rocks were more dense than water, so they sunk, maybe.
So what we have here is a rock and a piece of wood, right? So this is Jessica carrying it. If she takes just the rock, which takes her more time, all right, and she drops it in there, we know from your guys' experiment that the water displaced, right? She takes the wood, which takes much shorter time for her to transport to the well. It floats.
I got something about that.
Yes.
Okay, so wouldn't it be better to have at least 2 pieces of wood in there so you wouldn't drown, so you have something to hold your head above water?
That could buy me a little more time.
Yep.
If the rocks were heavy, it could buy me a little more time, but it's still not gonna get Levi out. I can't just leave Levi and just walk back and just be like, well, whatever, Levi. I gotta get Levi out. I mean, I might not know
How to get back.
how to get back because I'm not as familiar with the area as Levi
But see,
is.
if you look right here, how it's floating, it's floating up to 50, so you can climb up the top of it. If you throw like rocks down, then it doesn't
Not if
move.
it's stirred because he's already done. Okay, so, I just wanna we're gonna wrap it up a little bit about water displacement. The water displacement, if we started with 30 and you got 35, then the water displacement would be like the total amount that it moved up. So it would be 35. Like if it moved up 5, then the water displacement would be 35.
So, all right, while what we're going to do, or what we did with this, is we weighed the rocks, right? Okay, and that gave us a mass, correct? All right, so here's the thing. While mass is not necessarily weight, for us, that's what we're using in order to guess how many rocks, right? So this is so that we can measure the size of the rocks and what kind of rocks that Jessica should use in order to help me get out.
Now, volume, the way you find density is you have to use volume. So the volume, the way the differences between that and water displacement is, if we did the same thing where we started with 30 and you ended with the 35, you would have to take the 35 and minus the 30, and then the volume would actually be the 5 milliliters. That would be the difference.
So using the mass of the rocks that you found, right, or wood, and dividing that by the volume gives you what we call density, okay? And the reason that we want to know that is because we want to know whether or not we should use wood or rocks, okay? Because if we were to measure the wood, we would have to look at whether or not it's denser than the rock. And from our demonstration, we can see that.
Also, just to let you know, the measurement for volume, the reason that you use centimeters cubed, I know that seems a little weird when you're looking at the milliliters or whatever, but the reason you would use that is because it would be like a cube. Volume is length times height times width. So that would be 3 measurements, so that's why it would be centimeters cubed, so don't get confused on the units. All right, now if you would like to, I know that y'all all have some envelopes that said do not open on them. If you want to open them now, that is your individual assessments. I want you to work on them.
So pass
Individually?
them out to
Can you
each
write
of
on
your
these?
groups.
Yes, you can write on them. Put your name on there, and I want you to answer all 3 questions. Are you going to get anyone?
It's all the same.
You really want to write on it?
Yeah, you can write on it.
Their results.
There is a calculator included in your packets. Yeah, you can write on it. Go ahead.
If you guys put each of your names, so these are all guys.
Do we need to make sure? There you go. There you go. There you go. Sorry, I wasn't sure how many groups of 3.
And time.